Hello guys, this is CodeNCode and this is video editorial for the problem base exploration taken from SPOJ. So this is one of the latest SPOJ problems. As you can see, if you go to the home page of SPOJ, you can find the latest problem, and in one of those latest problem you can see base exploration problem is also there, which requires the knowledge of little bit of bit manipulation but of number theory mainly. So we are going to solve this problem. So the problem is very simple. You are given an integer n which can be as large as 10 to the power 12, I guess, and you have to print the base b such that basically you have to represent n in base b, and you have to choose b such that when you represent n in base b, it has most number of zeros at the end of it. So in fact most number of zeros. So okay, we have to print the smallest base. If there are multiple b such that they are having equal number of zeros when you represent n in base b, then we need to print the minimum one. So let's see an example. First of all, there are 10 to the power 5 number of test cases, and in each test case n can be as large as 10 to the power 12. So now if you see, there are two example test cases, 72 and 18. 72 when represented in base 2, when you represent 72 in base 2, we are having certain number of zeros. You can count it yourself. Similarly for 18, 3 is the answer because 18 can be represented in any number. In fact, there are infinite number of bases you can choose from, but when you represent 18 in base 3, it is having most number of zeros at the end. I think there'll be 2 zeros when you represent 18 in base 3. Now important hint, as you already know, now from some time I used to I like it to first give some hints so that you can try and solve the problem yourself. So first hint for this problem is a question. Basically, what happens when you multiply a number in base b with b? Basically what I want to say is that suppose you have written some number in base 7, so it has some xyz representation, some number n in base 7, and it has certain representation like xyz. What happens when you multiply xyz with 7 again? Let me show you an example. So the answer, of course, of the first hint is we get 0 at the end. Now let me show you one or two examples. See, 3 to 1 in base 10, when you 3 to 1 is in base 10, and when you multiply it with 10 you get 3 to 1 0. You see, we get 0 at the end. Now 101 is actually 5 represented in base 2. When you multiply it with 2, basically with base, you get 1010. Again you get 0 added at the end. So whenever you multiply a number written in base b with b, you get an extra 0 appended at the back. This is one of the most important hint. Now for this, try to find a relation between this and the left shift that we have studied in bit manipulation course series. In bit manipulation course series, we have seen that whenever you have a binary number and you multiply it with 2, it results into left shifting. So try to relate these two things that we are studying here and the left shift, the addition of 0 at the end and the left shift thing. So now this is the most important observation to solve this problem. Now we need to find a number. Basically when you try for, say, for 18, let me show you what we can get from hint 1. Now see, if any number n is divisible by b raised to the power k, then n will have k zeros at the end when you represent n in base b. Again, if n is divisible by b raised to the power k and you represent n in base b, then we will have k zeros. Why is that so? You can understand it from hint 1. See, 18 is divisible by 9 raised to the power 1. So if you represent 18 in base 9, you would get 2 0. This is the base 9 representation of 18, and you can see there is 1 0. Why? Because 18 is divisible by 9 only once. Now 18 is divisible by 3 raised to the power 2, or basically by 3 it is divisible by, I mean, yeah, k, the value of k here is 2, so you are gonna get 2 zeros at the end of it. Similarly, 18 is divisible by 2 raised to power 1. At max, we would find the max k. 18 is also divisible by 3 raised to power 1, but we are going to get, we will be only observing for maximum k, because we want to find the maximum number of zeros. So since 18 is divisible by 2 raised to power 1, so we will get 1 0 at the end of it when we represent 18 in base 2. So basically, for a given n, as you can see, if you try to represent 18 in any base, you see 2 is the maximum number of zeros you can get, because of course to get k number of zeros, it must be divisible by b raised to power k. So we need to look for only the divisors of any number n or 18 here. Instead of only divisor, we will be fixing our focus only on prime divisors. Why? You can take 1 or 2 examples and understand why you should only go for the prime divisor. So what we are going to do, for each number we are going to find the prime which is having, basically for each number we are going to get its prime factorization, and we'll print that prime which is occurring maximum number of time. For example, 18, it is 3 times 3 times 2, so 3 is appearing 2 times, which means if you represent 18 in base 3, you are going to get 2 zeros, which is the maximum, and that is why we will be printing 3. Now for 36, I guess there is 36 16, no, 36, it is 36 times 2, 18's times 4, 18's times basically 18's times 4, and then 9 times 8. So 2 raised to power 3 into 3 raised to power 2, basically 2 times 2 times 2 times 3 times 3. So 2 is appearing maximum number of time, that is why we are printing 2 here. So the problem basically boils down to finding the prime factorization, or basically finding the prime which occurs maximum number of times in the prime factorization of n. If there are multiple number, we will be printing the minimum one, and that is exactly what I have done here. You see, this is my solution which gets accepted. So first, since I want to find the prime factorization which you can do in square root of n time. By the way, I believe that the test cases are actually weak, because if there are 10 to the power 5 number of test cases and n can be as large as 10 to the power 12, so at max I need to run a loop for 10 to the power 6 number of time, because I'm going till square root of n. Now if for 10 to the power 5 times I'm going till 10 to the power 6, the overall number of operation roughly would be 10 to the power 11, which would result in TLE, but I'm somehow passing the time limits. I do not know how. See, AC. So that the only possible explanation for that can be that the test cases are actually weak. So if you guys have any better solution, better in sense of running time, so for each number n, I'm finding the prime factorization of it. So of course we have already seen how we can do this in square root of n time. So what I did, I actually calculated primes up to 10 to the power 6 here. Using the sieve, I have calculated all of the primes and stored in vector of integer primes. So primes actually contains all prime number up to 10 to the power 6, and after that what I'm doing here, each time reading n, result I'm initializing with 2, because n is minimum to be 2. So that is why in fact it doesn't matter what you initialize result with, this is actually the result what we would be printing. Important is count. So basically we need to find the maximum k. Remember, if a number n is divisible by b raised to power k, then the answer is k. I mean, you can get k number of zeros at the end and your answer would be b. So count is actually k. So for each prime in the prime list, we are going till only square root of n. So if p square is less than or equals to n, we are checking whether n is divisible by this prime or not. If this prime exists in the prime factorization of n, we are counting the total number of k, basically total number of appearance of prime p, and then if k is greater than current count is equals to k, and result would be p. Otherwise, if n is greater than 1, which since n is being divided by p again and again, so if at last after running a loop till square root of n, if n is still greater than 1, it indicates the presence of it indicates that n itself is a prime. If that is the case and count is less than 1, of course the result is going to be n. This would happen when you go for certain, even if you go for 11, this is going to happen. You would come here and this would be executed, and finally you will print the result. So you see how we are solving this problem. We went for certain observation which were easy to figure out if you already know about the left shifting, binary bit manipulation, or basically if you know about the number system. So we went for certain observation, and after that we found out the solution. I'll be providing the solution. I'll be providing this code along with the description of this video, so you can use this as a reference. So thank you guys for watching, and if you have any doubt, query, or suggestion, you can print, you can I was going to say print so you can comment it in the comment section. So thank you guys for watching, and till the next video drops, keep coding. Thank you.